Welcome to class 42 of Python programming. We'll continue with matplotlib type 2 here, class 2. Again, we have to import pyplot as PLT. Matplotlib also it's here. If it's useful, we'll use it. And data is arrange. My question to you is, what is the type of data? We'll plot it, that's fine. Okay. What is the type of data? Who can answer? Or no, what is type of data? What type? Data is type NumPy, Pandas, Matplotlib. What type it is? What is type of data? Graph, plot. What is the type of data? Yes, what is type of data? Who can answer? NumPy. Okay, that's correct. So type of data is NumPy here because we have used this one. Also NP is here. Okay, so this NumPy data we can print. We used to print before, and now we'll use dot plot, and we'll try to plot this one. If you recall, PLT is this one, matplotlib.pyplot we are using. So PLT dot we have written, that way we are using pyplot functionality of matplotlib, and then data. So that way you will get this one. This is just a recap. We have already done it. So if you have only one here, X, Y, or data, you can replace it by X though. So print 1, 0 to 9. That means on X-axis and Y-axis, you have the same numbers. It's like Y is equal to X graph. Now the next one here, import matplotlib.pyplot as PLT, same thing. Here again linspace, this was there in NumPy. So again np dot, this one. So instead of writing a list, now we are taking from NumPy. And now you plot X is there, and you have to plot sin X, cos X, and show it. Simple. This is also kind of recap because we used already plot function in the last class. Now go here. If you check this one, how this is different from this? Here instead of np.sin X, we have written this one. Here there is no such symbol. You see, only sin X, cos X. So by default, you get this one. However, here if you check, we have this way. That's why we got this one dot. Okay. So if you change it and you write single one, run it, you got the normal one. So by default, they are the same. By default, it takes this one. You try with 3. There is a problem here. What problem it says? Yeah, illegal format string, 2 line style symbols. Okay. So this is not legal. So 3 will not work. You can write 2 here. Even both you can make 2. So both will become this way. Okay. Now instead, if you want to make a star, it will be allowed. You need not worry to see all the types available here. Wherever required, you will have to use. We are using sine and cos graph here. I wrote differently because you can differentiate. Even if you don't write anything, it will take by default this one. So you got this way. You will be able to know what is your sine graph, what is your cos graph. Sine function, cosine function, okay. Now comes concept of subplots. Okay, before doing this one, I think I have to go here. This one will try to run and we'll check. Okay, so what we are doing, I'll explain you line by line. This is how you will see the plot here. Grid structure we have already here. If you see, this is our grid behind. We never used last time x limit and y limit. LIM we write here. So x limit we have written now 40 to 160. You see 40 to 160. And y limit we have written x limit 40 to 160, y limit 0 to 0.03. Y 0.03 I will show you here. And x level smarts, see here x level, and y level probability, y level probability. So x level, y level, title, these things will be there. Okay, you need not worry. And x limit, y limit we are using this time. We didn't use last time, but yeah, you can use. Even if you don't use, it will take by default. Okay, but what we are doing, I'll show you. Dot hist, we want a histogram of data. Now what is data here? Mu sigma we have taken 115. Okay, so we are talking about a distribution whose mu is 100 and sigma is 15. Okay, so you want to know the numbers, so we can use random.randn. Suppose we want to take 10,000 numbers. So 10,000 standard normal numbers you get, then you multiply by sigma, then add u. Okay, mu plus sigma into z. What is x? X formula is mu plus sigma z. So z you will get from here. Multiply by sigma, add mu, you will get x. How many numbers you have? 10,000. Now tell me, can I print this 10,000 numbers? Yeah, I can print it, right? And it will be a numpy type. If you print the type of x, you will get numpy. Numpy comes here. Okay, numpy. Now x means, that means you will get here, if you write plot.plt.hist here, x, don't worry about these things, we'll discuss one by one. So we want to draw a histogram. Okay, that's all. Again, don't worry about this one, you leave this and leave all this, we'll discuss one by one. All others we know, it's not a new one. So what we are doing is we are drawing a histogram of 10,000 normal distribution numbers whose mean is 100 and standard deviation is 15. So this will give you standard normal. Then you write this equation, you will get normal distribution numbers. You know how to get normal distribution numbers. So if you run it, you will get this one. Okay, this looks like a normal distribution. Mu comes here, sigma comes here. So how mu comes here? Let's go. This was not there last time. We had lesions last time, if you remember. So here, if you come, text is new one, plt.text here, 60. Okay, So 60, see it starts at 60 mu. Again, if you are wondering how mu came here, mu is not present here. Suppose I cut these two, then what will happen? Check it. See, mu is not here. Mu. If you are fine with mu, then you you cut this. Okay. Even these are not sufficient. You have to write these within 2 delta. Okay. So if I cut everything and I'm fine with only mu sigma, then I can do this way also. Okay. See, mu you will get, sigma you will get. Okay. That's why we write this. Now within dollars, we have your mu sigma, you run it. Now this looks good. And where it will start, it should start, suppose it starts at 60, I'll write it 160. What will happen? Check it. So it starts here. Okay, 160, remember the end here, 160. This 160 comes from here, this one, X limit. Okay, so because 160 is here, it starts at here. So better you make it 60 or maybe 50. Now see, it starts here. This 60 comes from this one, this 60. Okay, it starts here. This is 60. Then 0.25. Okay, if I make it 0.75, suppose, then see here where it goes. Okay, so make it sure that it should be within the limits. Okay. Mm, let me write 0.15 rather. Still it's here. Okay, 0.15. So let me write 0.25. Now it's here. See, 0.25, 0.025. It's here. Okay. So these things you can set so that whatever you want, you will be able to write here. And these are the labels, histogram of IQ. We have written here exactly whatever you write. Probability, smarts, these three lines we write all the time. Okay, so that we get things here, the text, that's all. Even if I don't write X limit, Y limit, there won't be any problem. Okay, it takes by default, whatever is required for this kind of a graph. Now this part is over. This part is over. Okay, if you don't write grid, this also we discussed last time, you get a graph only. Okay, so if you want grid, then you write this. That's all. So these things are fine. Now come to this one. Coming to this line here, histogram. Now X, we have taken 10,000 numbers, and density 1 or 1 you can write. Okay, this is Boolean. And this color, if you want, you can change it to blue and some others also. I'm not going through the details here. Just remember, this way we can draw the graph so that whenever you see, it won't create a problem. And let's continue with blue. Okay, now every time I get the same graph. Why I'm getting the same graph every time? Because this is random. Okay, if this is random, then the numbers of X are random, right? So when you draw the graph, every time you get same numbers or you get different numbers. That's how this comes into picture. Okay, we've written random seed 802, and that whenever we run it, it runs. That means you are getting the same numbers. Okay, suppose you don't write this line, then what will happen? Every time you will have new type of a graph. Okay, see here, another graph here, check here, another graph here. Okay, 1 2 3 here, though it looks the same, it's not the same. Okay, yeah, it's different. Okay, so if you write here, it will not change. Okay, let's stick to this one, because we change things and we want to test how other things will change by fixing this one. If you don't fix this one, then every time you will get a new type of a graph, because the numbers are not constant here. Random numbers you will get from this. Mu sigma, anyway you have to give, because we are using here. You could have written here as well. This has no meaning. This is required because you want to get the same random numbers, and these are the ones you have to write. You have to import here. Face color, acha, alpha, can you make it to 0.175? No, you will come across this one. We have scheme of RBG. Okay, this is still less than 1. Okay, that's how it's allowed. If you write this way, see the color. Okay, but if you write 1 point something, it will not allow. Remember, it's 0 to 1, like this, 0 to 1 range. You write 96. See, this blue is different from, I wrote 0.75 whatever, or maybe 65. You see this blue. Okay, that you can use. And color blue, green, whatever, it's a density now 50. Suppose I write 5 here, then see how you are getting. Okay, so you got a histogram where if you count here 1 2 3 4 5, if you count this way, okay, total bins. Okay, we say these are as bins here. So sometimes you see we write n here, bins here. It's not there, we have just started. Okay, not a problem. But 5 bins here. Okay, 50. Even if you want to write 500, it will look this way. Small, you can say very small, the thickness is very low. Okay, small horizontal vertical lines here. Okay, bars you can say. I'm not using bars because that's used for a different reason. Okay, now let's stick to 50. Okay, now this is over, and this line is over. One more thing, suppose you take less numbers, 10 numbers, how it will look like? See, this is not a normal distribution. Okay, the problem is with 10 numbers, what you can expect? 10 numbers only. You make it 100 or 1000. 1000 means it's kind of okay. At least you can say that, okay, I've taken 1000 numbers. I got a shape like a normal distribution. Now 10,000 we took, you take more. See, it looks very nice. So the more you take, the more numbers you take, the better it is when you are simulating. I'm not printing, so it should not take any time, but yeah, still it's a problematic thing. The more numbers you take, the better it is. Now, if you want to show it's like a normal distribution, even we can draw another here like a normal distribution. We can draw another one here, which will pass through the midpoint of the bins. Okay, you just write one point here, midpoints. You take the midpoints here and join all the midpoints by lines or by one curve you can join. Okay, then you will get this way on the top of this. I'm not going to that now. That's also easy. The same thing we do using ggplot2, similar here. And if you check this, how many numbers we have here? 100,000, 10,000, 1 lakh, 10 lakhs, then maybe 1 crore. Is it 1 crore? Yeah, maybe 1 crore. Okay. 1 crore numbers we have taken here. And it's 100 mean. You check mean minus sigma to mu plus sigma. That way 100% it's correct. Okay. Looks like normal. All right. Let's stick to wherever we started, 10,000. Okay. Run it. Yeah, this much. So now X level you know, Y level you know, title you know, text you know, X limit you know, Y lim you know, grid already you knew, so you knew. Okay. We'll see some more things. Now if you check last time class here, I wanted to compare it. Okay, just a minute. Here, I think it's there here as well. No, it's not appearing. Okay, no problem. We are doing this one, right? Okay. The last class. Okay. Continue with this. This is today's class only. We started with this one. Now we'll go to the next level where we'll try to know about subplots. Remember when we write subplots here, that means you have more plots. See, this is only one. This is one plot. Okay. So by default, it's always one plot. If you don't write, if you combine the last class and today's class, we have always one plot. Now you want to have more plots, okay, in one space. Same thing we can do in R programming also using ggplot2. Here the syntax is this one. We write this way: plt dot subplots, and here 0 0 means the first one. This is 0 0. Okay, and 1 0 means this is the second one. Second means this one. First row, 0th column. Okay, that way. This one. And 0 1 0 1 means this one, and 1 1 means obviously the last fourth one here. This one in red, this one in blue. See, you see in blue. This one in green. Tell me, Anu, this color. K is written. What is this color? For me, it's black. Okay. You girls, you can say you know more colors, right? So here we have 4, and when you write plt.show here, you will see all this. So it's a new style. Okay, dot plot we write, but we have 4 plots here. For that, you have to mention. Okay, suppose I write 2 here, then what will happen? I will write 2 here. Why there is a problem? Because things are not matching. Okay, whatever you have done that way, it's not matching. If you write this way, then what will happen? See here. So if you want 4, you have written 4 here, then you have to write 2 2. Okay, can I change it to suppose 4 4 0? Can I change it to 4 0? What will happen? See, 0 is out of range, right? What it says? 0 is out of bounds for axis 1 with size 0. All right. So 4 into 1 is 4. That would have been better. In spite of that also, there is a problem. Because we already mentioned this way here. Okay. 0 0 1 1. So you can write something here, something here. So here in this case, you can write only 2 2. Okay. So these are the 4 plots. So individual, if you see range 100, okay, so numbers you got here. Here sin x, 10x, if you remember the graphs, otherwise just for visualization. This one comes from this, but why you got this graph? 10x. Maybe you need more numbers. Yeah, it's there actually. You know 10x graph? See, the graph is like this. If you change it to, suppose, we'll make it more. It create a little bit problem, but yeah. Now still it's not good. Okay, you make it 10. Yeah, I mean with 10x it's very difficult. 100, okay, no problem. Let it be whatever it was. Run it, key proper. It's not straight line. Okay, that's what you need to understand. Now coming to this one, see, we have written subplot 2 here. 2x will be an array of 2 axis objects here. So when you write 2 here, you will get 2 graph, and one is our sin x, cos x. We've written by 0 1. Okay. Now if you write 2 1 here, suppose, then see here 2 1. Even I can write 1 2 here. I mean with this space, maybe it will be smaller. Yeah. I mean the graph is same, but you have to see the space. This is better, right? 2 1, or maybe you write just 2. automatically it will come down. This, then this, 2 or 2 1 is better. Now plot dot figure, it's optional, okay? But if you want to write figure size, you have to use this one, size. So white grid, okay, style for that we use. You know the syntax of fixed size we used already. You remember the syntax of fixed size? Any of you?
No, sir.
No. Fixed size only you have to write FIGSIZD. Okay.
Yes, sir.
12 8. See, it became very large now. Okay. So if I write 6 here and 4 here, suppose. See, this was our default one. Maybe you make it 666, you check it, you get this way. Okay. It looks like a square now. See it, 1.0, 1.0 here. Looks like 1, 2, 3, 4, 5, 1, 2, 3, that one. So you can write fixed size here. You write 2, 2. Remember, this is optional. This is so small now, right? Figure size. Here one, like a square. So the thing is here, if you want to get a bigger size, okay, and it's like zooming. So this is optional everywhere. This is optional. Even if I don't write this, then also it won't create any problem. Okay, you will have a size, default size. So you write this one only when you write big size. Though in many places you will see like this. Without anything, you will get this way. So you need not worry. That means it is no use. It's there. So whenever we want and we'll see there is some problem, then we'll use that one. Okay, within. Otherwise, we'll not use. Now, how this is different? Yeah. Now comes lean space. This is again from numpy np.leanspace. We have taken numbers from 0 to 10 only. 10,000 numbers here with equal space. So you can see here. And AX is here. AX dot plot you have to write. This syntax we didn't use before. And when you write dot axis this way and you write dot plot here, you write np dot sin x, because we have something. Yeah, we can't cut that. So here AX and figure combined, you will go to that. Maybe we have before. See here, figure X combined PLT dot subplot we have written this way. And here you see, no, this is already over. Though we have written separately there also. Here also if you see, AX and figure we have written separately. Okay. This is for PLT dot figure. This is dot PLT dot axis. And we are using AX here, AX dot plot. Okay. And this way you will get this kind of a graph. This is a new style. And this is not new. Sin x cos, this is not new. And here just np dot sin x 0 1, all that with this written, it's not new. I'll send you this one, you can go through. This one also line plot, these are not new. With x limit, y limit, already I have said you can go through this one, not new. Yeah, these are not new. Okay, nothing else is there. The next one I will start in the next class. I will not continue here because yeah, we can do this one as well, up to this to 24. This one already you know, plot I discussed last time. So you have to write this way and you can continue this. And then what will happen is the variations also you can complete here. This is outer box. Yeah, this one. How to draw one one curve here passing through all this. Okay, up to this one you complete. And also if you want here, suppose uh, you want to get this kind. Okay, the what are these are the 1 2 3 4 pentagon or whatever you say, this way. And I will show you the next one also. See, I got this way. Okay, so how to get this, those things you need to know here. Here specifically it's there. And different way, suppose you have written gray here, minus b here, line width here. So lot of things will come. You are not supposed to remember anything, but whatever is there little bit, if you know, means that will help you. This is what I wanted to show last time. I don't want to start this one today because it has a connection with lot other things. The next one, these things contour plot, so we'll do later in the next class. For today class is over. I'm leaving now. Thank you.
Thank you, sir.